1980s LA. Radio shatters silence. Rookie Cessna trainee asks ground speed. Tower replies, 90 knots. Soon. A twin-engine Beech smugly asks tower ground speed. 120 knots. Suddenly, Navy F-18 asks ground speed. Tower, 620 knots after silence. Mystery plane asked same question. After a long silence, Tower replied, I show your ground speed is 1,942 knots. No one asked again. Early in the Cold War, nukes and missiles drove the US and USSR to seek intel. Ground and sea spying was constrained. Satellites weren't ready, so high-altitude planes emerged. Americans moved first. Lockheed's U-2 at 20,000 meters pierced Soviet heart. Altitude outranged Soviet missiles, letting U-2 roam over USSR freely. Soviets weren't soft. 4 years later, May 1st, 1960, they downed a U-2, soaring wreckage and pilot. It pushed America to build a new spy plane. High, fast, front stealth, handed to Lockheed. Finally, after 4 years, Skunk Works birthed the unique SR-71 Blackbird.
Even if you say you don't need me, I'm going to do it. I'll be the one to end it.
Lockheed raised SR-71 from U-2 to 24,000 meters, near space. But Blackbird's edge over the U-2 was speed. Outrun every SAM. Never get shot down. So Blackbird hit terrifying Mach 3.2, yet it brought unprecedented challenges. Airframe heat materials. Above 20,000 meters, air can be minus 50 degrees Celsius. Yet the Mach 3.2 Blackbird's skin tops 300 degrees Celsius paradoxical. Can't cold air cool it? Actually the opposite. Introduce fluid dynamics' idea. Stagnation temperature when the flow stops completely. Imagine Blackbird at speed. Air on its skin stalls, converting motion to heat. Spiking temperature. In cold air, the plane's skin heats. Stagnation temp formula shows SR-71 at 20 kilometers, Mach 3.2, about air 816 K, 543 degrees Celsius. In heat, aluminum weakens, can't support aircraft frame. Thus, Aviation first widely used titanium alloy. Yes, Bone-hype titanium alloy was mastered by aero engineers 60 years ago. Americans found domestic titanium alloy output couldn't meet SR-71 demand. Worse, source was rival Soviet Union. What now? Can't trigger Soviet titanium aid. Finally, CIA's European front quietly shipped Soviet titanium home, fixing airframes. Engines became next hurdle. Low speed. J-58s worked as turbojets. Air enters intake, compressed. Fuel burns in chamber, producing thrust. Above Mach 3, everything changes. At speed, 3,000 plus M air enters per second. Intake shocks may flame out or crash Blackbird. Lockheed struggled years until Ben Rich, Greek fluid god, designed special body sans computer CFD. On ground or subsonic, inlet spike stayed forward. Above Mach 1.6, it slid aft. No fly-by-wire, purely mechanical hydraulic systems, precisely shifting inlet cone slows supersonic air to subsonic, regulating temperature and pressure pre-engine optimally. Some air bypasses the compressor, enters combustor, effectively giving Blackbird 2 turbo ramjets. Each SR-71 J58 makes 160,000 shp. This even exceeded Yamato and Essex ships' shaft horsepower. Such engines need special fuel. JP7. At Mach 3.2, SR-71 surface tops 300 degrees Celsius. JP7 must stay stable, not ignite/vaporize easily. JP7 did more than power flight. It cooled the airframe and pipes, warming fuel to optimal engine temp twofold. That the Blackbird guzzles fuel. Engines and unique airframe design. Built with gaps for expansion, the Blackbird leaked fuel on ground and subsonic flight. Stable JP7 kept crews safe. Even US military hated waste, so Blackbird carried minimal fuel. After takeoff, full power heats airframe, sealing gaps. Refuel aloft when leaks stop. Then mission. Tech-packed Blackbird rolled out December 22nd, 1964. First flight broke records. Despite 383 unsolved issues, brave pilots flew Blackbird to 15,000 meters. Supersonic. 3-year testing. Close calls. 1967. Lockheed fixed all. Blackbird finally in service. Pricey plane returned shocking intel too. With cameras and Kodak film, Blackbird clearly imaged D4-size objects from 30,000 meters. Blackbird first deployed in Vietnam War. High-res intel helped B-52s strike accurately. Mideast. 95% Blackbird imagery. Missions weren't always smooth. Instead, Blackbird deep inside faced threats. It wasn't truly stealthy. Despite Lockheed shaped the SR-71 Blackbird's sleek fuselage and black stealth coating, its RCS was only eagle size. Shockwaves and twin plumes made Blackbird brightest at night. Radars spotted this Mach 3 Eagle in service. Blackbird dodged fighters and 5,000-plus missiles. None were ever downed by SAMs. Pilots seize missile launch. Floors it. Escapes. You see me miss. Yet it unexpectedly retired suddenly in 1989. Late service Blackbirds went to museums, labs. One crossed US in 68 minutes. Middle East turmoil prompted USAF to revive Blackbird, but Congress debate stalled. Eventually, replacement Blackbird retired before the U-2, lying quietly in a museum now. You've heard. Upkeep, upgraded Soviet air defenses, and military satellites leaving Blackbird pointless. But I think it ended from human hearts. Lockheed engineers built Blackbird with potential. Recon was Phase 1. Skunk Works wanted a fighter. After SR-71 success, YF-12 finally surfaced. Then Lockheed, at its peak, crossed the wrong defense secretary, Robert McNamara. SR-71 impressed Air Force. Key intel reached the president directly. Thus Lockheed earned esteem in Air Force in Washington. It irked Secretary Robert, feeling bypassed. After hard fights, Lockheed yielded, cancelled YF-12A, dismantled SR-71, killing Blackbird. Fastest spy plane dodged fighters, outpaced missiles, but fell to power politics. Blackbird lived on. NASA took 2 for study. Lockheed kept studying stealth. Skunk Works birthed world's first F-117 Nighthawk. Later, Blackbird appeared on screen, known as Transformers 2's Jetfire. In 2018, SR-72 rumors spread, claiming over Mach 6. But today's battlefield of satellites and drones challenges SR-72 more than SR-71. I met Blackbird in a 2009 magazine, Raid 2. Its sci-fi design amazed me. Bugged Dad into First Aviation mag. New World. Now I'm a Sydney University Honors Mechanical Engineering graduate. Turned from aviation fan to writer. To spark more aviation love. Join me in exploring the technological marvels that soar above the clouds.